Okay, so I'm creating the project now. Let me correct this. 002. Next simulator. Add, and I'll just call it discussion 6 and go next, and I'll add a new source file. Oops, I'm just gonna create a new one. So again, discussion 6, you can name it any way you want. Yeah, so now I'll copy and paste the code that comes with this discussion, and yeah, so let's run this and see if it's, yeah, it's built successfully, so it's good, no issues there. Yeah, so now let's follow the steps in the PowerPoint and set things. So we want to have I'm just gonna stop this, and so let's have breakpoints in here and in here, so when we clear the flags, and add watches, so we want to have video debugging watches. So okay, why it's not showing up? Oh yeah, it's here, sorry, my bad. So I'm just gonna move this one here. Nope, not there. Yeah, so yeah, so we want overflow, number, cycles, and timer 1. Yeah, there are too many things here that I have to get rid of, but yeah, let me create those variables. So again, overflow, that's one, and other one is number, cycles, and hit enter. I hope I typed them right. So timer 1. Okay, I'm just gonna move them to the top so that we can see them. Yeah, it's still, yeah, I'm just gonna take this down. Okay, so now we have those 3 things. Timer 1, number of cycles, and why overflows go there, I'm not sure. Anyway, so these are the variables that we want to watch. Now we go to window and we go simulator and we open the stimulus. Okay, so and we go asynchronous here, and it's already in here, so we select int0, here, and we set high, and yeah, so we set high, and then we add another one, and we set it, so you just click here to another line, and we set int0 set low, and then we add another line and we say same thing, int0, but this time pulse high, and we put the value 50,000. Okay. Okay, very good. So then in the next slide, it was talking again. You can open, go back to that part of the video, and I'll also put the discussion PowerPoint, so you can just open from there too. Now we're gonna simulate the program in debug mode, and then we will see what happens, what's happening here. So I'm just gonna make my screen a little bit bigger. Yeah, sorry, it's not going down. Okay, so let's do this. Okay, so we can watch our watch what's happening. So like with the overflow, number of cycles, and timer values. Currently overflow is 0, number of cycles is 0, and timer 1 is 9. You know, it took 9 cycles to come here, as it looks like. So then we can, just a second, they changed the, let me, so obviously, so I mean, if you just keep doing it, it's just gonna be inside the while loop, and it's not gonna be able to exit this one, because I mean, if you don't have any interrupt, I mean, it's just gonna keep doing this, right? So I mean, this is the main, and as long as unless you have an interrupt, it's not gonna, you know, exit this infinite while loop, right? So then what we do is yeah, so now we're gonna trigger row 1 from the stimulus. So we're gonna go to here, and we're gonna trigger this one, okay, and then we will switch back to watch panel and observe timer 1 as you single step into ISR. Okay, so we'll trigger this one, and then we will go to watch, and now we will step into, okay, so now interrupt happened, and you know, when interrupt happened, when timer is hit 15,999. Okay, so that's when this interrupt happened. Okay, okay, so then I mean, we had I mean, and then just move on. Let me now trigger the second one. Okay, so low. Okay, and then again press step into few times to, now we have another interrupt happened, so we are at this point here, and let's look at the watch values. Again, let's look at the overflow. So let's see, let's show it in binary, I mean in decimal. So it looks like we have 11 overflows during this time, and current timer 1 value is again, I'm just gonna show it in this decimal. So 113, and timer, like the PR1 value is 15,999, and yeah, so let's just keep going. So it's just gonna follow those steps, and then it's gonna go back to the main, and after here it's just gonna keep stay in the main. Obviously, as it waits for another interrupt, at this point it's just timer 1 is going up, and nothing else is changing, right? So since we you can just kind of play with it, and you can try and trigger row 1 and row 2 in the stimulus and play with it, just observe the variables. Let's move on with the PowerPoint I had. So question here is, what will happen if the external signal went low before this line, right? So basically, once, let's say, when we have a rising edge detected, now in the interrupt we are saying, okay, now detect the falling edge with this line, right? So we change the edge detection, which edge we want to detect every time. So first rising edge, and then falling edge, and then again rising edge with this line. So what will happen if the external signal went low before this happened? We are assuming it's not that fast, but if that happens, what happens? You can stop and try to answer the question yourself. Here's what happens. We will miss the falling edge and will instead catch the falling edge that was part of the next cycle. Okay, so basically what happens is, if this happens very fast, okay, if this happens like from here to here, well, we have, let's say, rising edge, and that line is now asked like change the interrupt to detect the falling edge. And if external interrupts turns into falling edge before that line runs, then what's going to happen is we are gonna detect the falling edge of the next cycle. So instead of detecting this one, because this is gonna happen before that line runs, so we're gonna detect this one. Okay, so we're gonna miss one falling edge there. So then it's always, you have to watch these things. So our ISR needs to be less than minimum pulse width we are attempting to measure. Okay, so if it is our pulse width is very tiny, like 10 cycles and things like that, you have to be careful with your ISR. So it's, as always, like I mentioned before, it's very, very important to keep the ISR short. You don't want to do like a lot of data processing, things like that, and a lot of calculation inside ISR. Okay, so ISR should be very simple, few lines, clear the flag, do whatever you do, and leave the ISR immediately. So you don't want to stay there long. Even if you do your best, if you are trying to if your pulse width is very, very small, let's say 5 cycle, 10 cycle, you might not be able to what I'm saying is here, like in the interrupt, like you have this stuff, right? So you do this. I mean, you have a bunch of like lines here. It takes a lot of instructions to take care of all these. Like you have if statement and things inside if statement, else, and so forth. So this part might be taking like 50 cycles, let's say. Okay, I'm just making it up. If your pulse width is less than 50 cycles, you are not going to be able to change this before you are not going to be able to run this line, and that's why you are not going to be able to catch the next falling edge, because it's still detecting the rising edge. And and to get from here to here, if it is taking, let's say, 50 cycles, and any pulse with less than 50 cycles, you're not going to be able to catch the falling edge, right? So that's why you want to keep the interrupt, in general, as just a rule of thumb, you want to keep your ISR short as much as possible. And if you can do your best, but then based on your need, you might have to do something else. Again, it depends on the condition and what you are trying to do. Just be aware of this kind of stuff. The code might be okay, everything might look perfect, but it might not do. You might be getting different values than you expected because of this kind of stuff. Okay, so let's follow these steps again. I was just playing with it. So what we're gonna do is press F8 a few times, single step back into main. So if you are trying something else, let's say, with it, so you can just hit this one a few times, or step 8, F8 a few times. So you are in the main now. So obviously, since you don't have any stimulus, it's gonna stay there. Then what we do is we trigger roll 3 from stimulus, and we switch back to watches to just see how variable changes, and then we will press F5 to enter INT0, and then another F5 to enter timer 1, and another F5 to enter INT. Sorry, again, I'll explain here. Then we press F8 to single step until it goes until the line where number cycle is set. Okay, so let's do that. Just gonna run this, and I'm just gonna go into the main. Okay, so I'm just gonna go into the main here, just step into and just go to main. So at this point, since I don't have any stimulus, I'm just gonna jump here and just basically loop here, infinite loop. So at this point, I hit pulse high. Okay, I switch my watch to here. So number of cycles obviously 0 here. So now I'm gonna hit F5. It's gonna take me to INT0 again, like it says in the PowerPoint, because now I detect the rising edge. So, and I hit another F5. Now it went to this interrupt ISR, the timer interrupt ISR, because now I'm having overflow, and it's detected that. So because we have multiple, so I have to hit again, and one more time. So now I'm in back to INT0 again now, because it's detected the falling edge. So now at this point, I'm gonna stop for hitting F5 or continue, and now I'm gonna step over. So go line by line. So again, watch number of cycles, and okay, so at this point it's gonna calculate the number of cycles. If I hit again, 50,000. So again, we were able to measure the stimulus input, right? So stimulus was providing that RB7 pin 50 cycle high pulse, and we were able to detect rising edge and falling edge, and then we were able to calculate the difference in terms of timing between them, and basically we were able to calculate number of cycles from during that pulse, okay, like high pulse. So that's it. That's basically what we need to do, what we expected here, and that's what we got. We have a question. Maybe we can kind of talk about that one. Could we set PR1 to 65,535 to maximize the number of timer counts per overflow and minimize the number of timer 1 interrupt? Well, answer is yes, right? Obviously, in the current setting, it's PR1 is 15,999, so you will have more overflows. And if your PR1 value is higher, and then of course you're gonna have a less number of interrupts. Okay, so it's gonna do the exact same thing, kind of, but so yeah. The answer, like I said, yes, but let's go over this. This will also allow us to reduce the number of cycles needed to compute the number cycles, right? Obviously, and 32-bit integer multiplication is expensive. So, yeah, that could, save some like a number of instructions that take care of the job. So yeah, so that would work too. So instead of this one, we can replace that line with this line. Again, you gotta think about this line, what it means, and try to understand what it means. So we have number of overflows, and we are shifting it by 16-bit and ORing with the timer 1 value. So it does the same job, but of course this is less instruction cycles.